Hey everyone, welcome back to Coursera. Today we are again back with another problem solving question. And why I said again? Because I am recording this for the second time and it is happening so frequently nowadays that I have to record a video multiple times because some things comes in between my video, some interruptions. But still, let's continue with our series. Today's day 38 of our level up series. As we have already done recursion and backtracking question yesterday, today we are also following off with the same similar question, not the same question. Same concept will be applied there. So now let's see. Let's go to the lead code. Try to think of like how we can solve this problem statement. So let's go to the lead code and see the problem statement. So that's where we are. So subsets is here. That this is the problem statement. Doing it in a traditional way, taking out the screenshot, going in our background here, then trying to find the solution of this problem. Okay, so here we are. So it is like a subsets question which is given to us. Given an integer array nums of unique elements, return the all possible subsets which we have. Now, returning all possible subsets is generally means if the array is given to us like 1, 2, 3, then we have to return of all possible subsets, and they have given it like 1 will be the empty, 1 will be just having one element, 2, 1 and 2, 3, 1 and 3, 2, 3, 1, 2, 3, in total 8 elements. And if we have to calculate of if there are n number of elements in the array, then number of subsets will be 2 raised to power n. That means 2 into 2 into 2, and it eventually means 8 elements will be there. So from the empty set also we have to include, because we are talking about the power set. So in all possible subsets, the power set is also like a case of all possible subsets, including the empty subset also and the subset with all the elements. And that's how it works off. But still, it is like a solution must not contain any duplicates, and we can return it in any of the order. So solution must be like not containing any of the duplicates. It means if there is one and two, there should be not two and one. Okay, we can conclude it like that because both are similar things. Only so in total 8 elements you have to return off if there are 3 elements. Just simple thing, making of subsets. Now let's think about the problem statements, intuition, or we can say the logic which we will be applying here. I'm not going to go into the brute force. You can think about the brute force, but I don't think so. It is useful right now because we have moved to day 38 of our level up series, and now your level should be that much up that you can directly jump into the backtracking or recursion. So for practicing that specific problem only, backtracking and recursion, we'll be solving it in with the backtracking and recursion only. And the time complexity is the main factor. The time complexity which we will be having is 2 raised to power n instead of n raised to power 2. And 2 raised to power n generally means it have exponential time complexity instead of having longitudinal time complexity which we will be having with the brute force. So now let's deep dive into it and see how we can find the solution for this with the help of recursion. So first of all, if we have to make a recursive call and in the problem statement it is written we have to return in the form of vector of vector type int, it means a 2D vector which namely a vector which inside which we will be placing our answer or the subsets. So that's what we have to find out and that's how we have to work it off. So firstly, we will be starting off pushing the values inside it, but for the pushing of values, we need to understand one thing, the logic which we will be implementing. If there is a recursive call which we are making, first of all, there will be an answer array, which is vector type. There will be a temporary array also, which has the temporary values. There will be a nums also, which will be normal nums array. There will be index also, which we will be having. Now the next thing is we have to find the base case and what will be the base case for this, because in the video number 7 when I first time solved the recursion, at that time also I told you recursion, for the recursion there is one thing which is foremost needed, that is the base case, because it will go for infinite if it doesn't make a base case. So base case will be if just suppose our index have reached till the value of our nums dot size. Okay, nums dot size. So index will be at the beginning it will be at 0 only, but then it will get increased up. And that's why we will be what we will be writing in this base case is whenever our index reaches the nums dot size, in that case In that case, in the temp, we have to push back into our answer. So answer dot push back our temp. Quite simple. In the answer, we'll be pushing off our smaller vector int and then returning it off because we have to end off the recursion at any cost. Now, next will be our answer, or we can like temp. We will be putting off the value inside the temp, but just suppose the answer which we have, how will we making of that answer? Is it like directly we can make it up? No. Firstly, we have to push some values inside the temp, and then we will be pushing that temp inside our if this is our temp, then we have to push some value inside this temp, and then this temp will be pushed inside the answer. So first of all, we have to do push operation. Okay. And just suppose if we just think about the push operation only, will our problem shouldn't work because we have to pop off the values also so that we can get to the every single solution which is possible. Because if you think about this statement like pushing a empty one, then it is not possible. So for that, first of all, we have to write a condition in which in the temp we will be doing pushback, and what we'll be pushing back is our nums index, nums index. And next of all, what we will be doing is we will be again calling the recursive function with same parameters answer, temp, nums, and index plus one. Quite simple. Then next will be like temp dot pushback. But do we need the pushback function again? We are again we will be ultimately pushing off the values, and this index plus one will ultimately let us to reach till the edge case, which is index equals to nums dot size, and then we will be pushing off the temp and then returning it off. So for reaching this base case, we are increasing the index, but just think about this case. We need to pop up all the values to reach this case. So that's why instead of doing the pushback, we will be doing temp dot pop back. So now we will popping back the values, we will be reaching till the empty. But in the recursive call, we will not make index minus one. Instead of that, we will be going off with index plus one only for sure. So we will be adding off the index so that we will reach the base case, but we will not be doing the push. Instead of that, we will be doing the pop operation. And that's how it will be working off. Now let's get to the lead code and try to solve it off. Too much of talk. Now let's try to solve it off. And we will be using recursive call, so it will be for sure in 2 raised to power n time complexity. So if you do it with the nested for loops, you will be getting n square time complexity. And this is way much better than that. Making vector of vector type int, and also vector type int of our array, and also nums. We didn't need, we just need a recursive function there. So making a recursive function of void, and void we have to make it recur, and that is like vector vector starts with b or not b, and that vector of vector type and operator will be there because we are trying to make a copy of it instead of passing it as a complete value. We are passing it as a reference because we want changes in our answer. Vector of vector type answer. Next will be our vector of type int, and this will be a temporary one in which we will be pushing off the values. Next will be vector of type int, and it will be nums, and at that it will be int index, which we will be having. Now let's write the condition. If our index reaches uh, our nums dot size, in that case, we have to take our answer dot push back, and what we have to push back there is our temporary answer in which we have pushed the sum of the values. So it is a sort of a subset which we have. Making the return statement so that our recursive call can end. Somehow it will find a mukti out of this bandhan. And next up is our temporary array in which we have to push back our nums, index. And at the end, we have to do recursive call again. Recur, answer, temp, nums, index plus 1. Okay. Now talking about the temp pop operation, pop, back. Now this time, now we just need to make another recursive call for the answer, for the temp, for the nums, for the index. And that's all. We are done with it. Now we have to call this recursive call here. Recur, passing of the answer, passing of the ARR, or like let's make it as temp only because ARR is a way more respectful word, but we are just making it as a temporary one. Temp, nums, and starting index is 0. And then we will be for sure doing the return, and return will be of our answer. Now let's try to run this and see if it works or not. If it doesn't work, we have to find a solution for this. It got accepted quite easily. Now let's submit this off and see if it works there then also or not. Mm, yeah, so it got accepted quite easily, and that's how we can solve this problem with the help of recursion and backtracking. So that's all for the video. I hope you liked it. I hope you will solve this problem statement. And that's all. I will be pasting the question link in description. Go and check out.